like you to do is put your results into an Excel file like this one that I've got here. You notice what I've done is just set up basically exactly the same table that I drew on the board for you previously, and I've just made up some results here. So these won't be similar to yours, but hopefully you'll be able to see what I see here, which is what I want to do is I want to actually do a calculation on this in this column here, the one that I said to leave blank, and I want you to take the voltage and divide by the current. Now I can show you the shortcut for that. All you need to do is press equals. Remember that the equal sign means to do a calculation. It's telling Excel to do a calculation. And then what you will do is you will click on your measured voltage, okay, and you will divide by the current and press enter, and it will do the calculation for you. 2 divided by 1 is 2. And I think that once you've done that, one of the interesting things that you should find here is that if you now drag down here and do that same calculation for 4 volts, 6 volts, 8 volts, 10 volts and 12 volts, if you use the measured result here, is what you should find is that the voltage divided by the current should give you a constant. Okay, and this basically shows us Ohm's law, which states that the voltage equals the current multiplied by the resistance, and that is basically what you have done here in this column. Is you've shown what the resistance is for that resistor. Now you might get wildly different results from what the other groups got, okay, and that's fine, but what you should find if you've measured it correctly and you've done the experiment correctly is that these should be they should be exactly the same, but they should be around the same number. You know, it is an experiment. We do expect there to be, you know, some errors there that you might find you might have measured not 100% accurately. You know, the difference between 2.1 volts and 2.5 volts or 2.8 volts or something like that as measured here is sometimes very difficult to see, but you should get a bit of a trend happening here. As I said, this is a thing called Ohm's law, okay, which states that the voltage equals the current times the resistance. And also, you can rearrange that formula. I should be able to rearrange that formula as well to say that the resistance equals, and obviously if I take both sides of this and divide by I, okay, the current, I get that the resistance equals V over I, and also I could do the same thing the other way where I could divide both sides by the resistance and find that I equals V over R. Okay, those three things are exactly the same formula. Something else that I'd like you to do with this information is I'd like you to graph it. Okay, so what I would like you to do is to, using Excel here, if I highlight this information here, these are the two columns that I want to graph against each other. If I go to the charts section and I choose the type of chart, probably a line chart might be the best one here. Maybe even this marked line chart. Okay, I do have to do a little bit of fiddling around with Excel here, and I need to select data. And what I want here is on the x-axis. On the x-axis, I want the current. So I want this information here. Okay, press enter there. And on the y-axis, okay, I want this information here. Okay, graph those against each other. And what I should see here, I think I can actually remove this current one here. Okay, and now if I do that, that is what I would expect to get, because what is happening in this experiment is that as you increase the voltage, you are decreasing, as you increase the voltage, you also increase the current. And that should make sense to you as well, because if we were to go back to our water analogy there, you could say that what you are doing when you are increasing the voltage is you are increasing the pressure or the power which pushes the water through the pipes. And that is exactly what we would expect here with this experiment, to say that as you increase the voltage, therefore the current should increase. at a proportional rate even. So what I'd like you to do as part of writing up those two experiments that you did this morning, remember there's one where you did some work on the advantages and disadvantages of series and parallel circuits. I would think that you should be able to come up with at least 3 advantages of series circuits, at least maybe 2 or 3 advantages of series circuits, maybe 2 or 3 disadvantages of series circuits, and then for parallel, there are at least a few big advantages of using parallel circuits, some of which we talked about this morning. You might also have a think about the brightness of the globes there as one. And then for disadvantages, you might come up with 1, maybe 2 disadvantages there as the sort of results of your experiment. Okay, so that would be your first experiment that I want you to write up from this morning. Then there's this one here, which is this is your results table, and this is your graph of your results. That shouldn't have current A there. You can fix that if you go into select data. And now, how do you fix that? I think maybe instead of using the x-axis labels, maybe just include those bottom ones instead of using the heading there as well. And I don't know what I've done here. It's gone ballistic on me, so I'm just going to leave that there for the moment anyway. Okay, once you have finished writing up those 2 experiments, I guess I will also ask Mr. Moran to come up with some work for you as well, just in case you finish. But look, I'd really prefer that you wrote up those experiments properly. I'm happy for you to just do that work as long as those experiments are written up properly. You should have an aim to both of those experiments, and a title as well. You should also have obviously the equipment, okay, and you want to have a method, and you want to have diagrams which are similar to ones that I drew on the board. But here is where I really want you to have a look at variables as well, and that for those variables you should have an independent, which is the thing that you changed in each experiment. You should have a dependent, which is what you measured in your results. So think about what you measured in your results here. I know you measured the voltage as well, but the voltage is also the thing that you change. So your dependent variable here is the current, okay, and you might also have to add some controlled variables as well. What did you have to keep the same each time? And there should be several of those, but there should only be one of these, and there should only be one of these, okay? And then obviously you would have results, and you would have a conclusion to each of those experiments as well. So I really would prefer if you did it properly. If with the one for the advantages and disadvantages of circuits you miss some of those, I'd encourage you to research that using Google, just to type in advantages and disadvantages of series and parallel circuits, just to make sure you've got all of them. And then you might actually, if you haven't got pictures of all of those, you could get some, again, you could search in Google Images for some of those pictures. I'm going to provide some work for Mr. Moran if you guys can't rush that and do that not the way that I want you to do it. But if you guys can do the right thing, there probably won't be any other work for you to do this lesson. So I'd really tell you, make sure you write up those experiments properly with all of those headings there, and you should have pretty conclusive results there. You should be able to list the advantages and disadvantages of series and parallel circuits. You should be able to do that. It's quite simple. Okay, and then you should be able to show that what we proved in this experiment was that we have this relationship where there is a relationship between the voltage, the current, and the resistance in a circuit. Okay.